Welcome to Weld.com. We have been asked to do, one of the viewers asked, can you stick weld aluminum? The answer is yes. I'm going to be real honest with you. This is one of my least favorite things to do. You can do it. I'm pretty proficient with TIG and wire. I like those two processes. They're clean. I like running the spool gun. This you can do some portable repairs. Aluminum stick is DC reverse polarity, electrode positive. What I have noticed in the past it depends on the type of weld you're going to make. We're going to try to do a couple of fillet welds here, front and back. I'm gonna guess and say the second one might go a little better than the first one. But this is 1/4 inch material and I need to preheat it. If we just went into this cold, I don't think we'd have a very good result. I think we'd need to run a little bit and get this material warmed up before this actually flowed in. This process is real gummy. This flux on here is kind of a heavy salt. I don't know how to describe it. It's just real spattery, turns into kind of a gray muck looking stuff on it, and it's a little strange if you've never done it. There's a lot of maintenance alloys out there, and some obviously run better than others. It's just like stainless electrodes and low hydrogen electrodes. Some of them run extremely well, some of them are a little bit rough, and that's the nature of the flux and flux composition. So our attempt here is, I'm going to get some gear on here in a little bit. And I'm gonna preheat this with an oxyacetylene torch. And I want to show a little trick here. I've got a temp stick. I couldn't find my temp stick that goes to 350. I've got one that says 250 on it here. But I want to show a little trick that I learned from a metallurgist that worked for Messer Gresham, MG company, maintenance alloys. There's a trick you can do with the torch here, and it's purposely putting soot on this piece of aluminum with a carburizing flame. And then I'm going to back off and change to a neutral flame, and I'm going to keep heating this thing up. When that soot disappears, you're right around 400 degrees. That's kind of nice when you don't have this stuff. It's just, you know, we're trying to saturate this with a little bit of heat. We don't want to get too extreme with it, but we really need that heat in there to get this to flow pretty good. So I'm going to get some gear on. I'll be right back. Okay, I need to preheat our piece of aluminum, 1/4 inch. We're try to do a fillet weld. Again, this is going to be a little rough. I already know that. So what I want to do here is I want to light this flame and make it purposely a carburizing type flame, excess unburnt acetylene or fuel. And I want to put it over here and make this black. I think I'd turn that back a little bit more just to get some immediate soot on there. So now I'm going to change to more of a neutral flame, and I'm going to get back away from it. And I'm going to start preheating this. I am going to use this 250 degree temp stick. And we're not quite to 250, and now we are. Aluminum dissipates heat 4 times faster than carbon steel. It also has an oxide layer on it, and I have pre-cleaned this with wire brushes, stainless wire brushes, which is one of the best ways. A lot of people I see will take abrasives. They'll just take a regular old grinding wheel that they've been using on stainless steel, or carbon steel rather, and they'll just stick it on there and grind away. Or they'll take a high-speed wire wheel bead brush, and they'll use it on the on the aluminum. And actually what that's doing is just folding the oxide layer into the material. It's not cool. File. You can use light sanding pressure, chemical etch, hand wire brushes are the best ways. I'm using a 3/32 electrode. I'm going to run about 85 amps. DC electrode positive or reverse polarity. I've pre-tacked this with gas tungsten arc welding. If you think that low hydrogen electrodes are kind of rough to start sometimes because they got the flux on the end of them, these are 3 times worse. I'm gonna make sure I have some bare electrode. So the technical specs for this, it calls for pretty much a straight end angle, fast travel speed, and I can agree with that. This weld pool, to me, it's got so much going on around it, and it's really active, and it's going to spatter quite a bit. So, you know, this is my first attempt in a long time. I use this occasionally, but I use it more out to repair something like a handrail or a piece of broken equipment on out in the field somewhere away from the shop. So let's see how this goes. It also, the technical specs call for a real short arc, and to me it feels like I'm just cramming this in there all the time. I had a rough start. You know, that's just the nature of this rod. So I'm going to let that kind of cool a little bit, and then I'm going to go after the back side here and do the other side with another rod. I may step over and knock the flux off the end of it with my needle nose or something, because that wasn't fun at all. You'll notice that I think it was somewhere about half, 2/3 of the way through, the weld pool just kind of exploded. But, you know, there's not a whole lot you're going to do about that. We've got some spatter on here. I'm putting a heavy block on here just to hold the material. You saw me pecking on this a minute ago. Well, let's hope we get a better start here. I think if I have a better start, then I can just go feed this in. Again, you know, if you're making a repair, you would be using some sanders, the flapper wheels with light pressure to grind and blend this back. You can do multiple passes. Again, another rough start. I wish that wouldn't have happened, but it does. Kind of hard to tell. To me, it just looks like it's definitely washed out here in the crater, and I tried to come in here and pull this back a little bit. I don't know that I got it filled up. Let me go cool this off, and I'm gonna have to work this and chip this quite a bit. What I don't want to do is grab a wire wheel and knock the flux off, because I think the aluminum is so soft that I'll just rearrange the whole ripple pattern. So I'm going to take a little bit of time. I'm going to quench it and take my slag hammer and lightly try to peck this stuff off of here. I don't think it'll come off. Stuff's pretty aggressive. So let me go cool this off, and I'll go to work on it and see if we can't bring out a bead here that you can see. Be right back. I'm back. I cleaned this all up. I told you this was going to be a little rough, and it was a little rough. You can see that I've used my pliers. I was trying to knock some of this stuff around. I used my chipping hammer. I'll show you in both. They've got this heavy salt looking residue on here, and that's just the nature of that flux. This was the first side we did. And I had this rough start right here, and it was a little cold. You can see that I kind of missed this right here. I'll tell you, when I struck the arc, I really couldn't see where the pool was at the very beginning. Now, after the electrode became active, and the arc force was making the flux go kind of behind the rod, then it was a little easier. And a couple of things to note here, you know, the spatter, I think I mentioned that about 2/3 the way down the weld pool kind of popped and exploded. I paused to recover, but it left a big old blob of aluminum out here. You know, we can clean that up with sanders and files. So, you know, we get an acceptable profile somewhat of an aluminum weld here. You know, it's not, those of us that weld aluminum with TIG and spray wire feed on a spool gun or even pulse spray, you know, you got to admit, wow, that's way rougher than what we're used to seeing. But, you know, is it welded together? Sure. Can we make repairs with it in the field? Sure. I'm sure if I use this more than what I do, I haven't done this in probably 4 or 5 years, but a viewer asked and we want to satisfy the viewers, so I'm hoping this helps out. So, and then this was the second side. Again, since everything was preheated, I did stumble a little bit on my start, but it blended in way better. I'm not sure why this came about. Another little blob. I thought I was doing better down here. And then right down at the very end, this is interesting because one thing I just despise doing, and I see a lot of people doing it, they come out here to the very edge of something and they stop. Now, I want to ask you a question. How many of you have seen beautiful aluminum welds like on trailers and they're cracked right down through the middle of them? And it's from this exact same thing right here. When we terminate a weld on aluminum, we need to fill this crater in. And this is a classic crater with a little star hole in it right here. Well, if you think about a trailer, it's under vibration all the time. But once that little crack starts in that little crater crack, that little star fissure, it just propagates right through the center of a beautiful weld. And it does it every time, pretty much. So we need to make sure that you fill these in. I'm sure that if I had to blend this, if this was a somewhat critical repair, I would clean this all up and attempt to go back in and fill that in. I wouldn't leave it like that, I don't think. But again, the whole demonstration was, can you stick weld aluminum? And the answer is yes. You know, I don't particularly like doing it that way, but it's doable, you know. So again, thanks for watching. Make sure you subscribe to the videos. New videos will come out every week. Thanks for watching Weld.com. I'm Bob Moffett with Cali College.